Hello students, welcome all of you. In this video, we will discuss very important topics: degree of freedom, law of equipartition of energy, and a specific heat capacity of gases of chapter 13 Kinetic Theory for class 11 physics, book number 2, in video number 2 or part 2 of this chapter. First of all, we have to discuss degrees of freedom. The total number of independent coordinates which must be known to completely specify the position or configuration of a dynamical system are called degrees of freedom. Alternately, the total number of independent ways in which the constituents or particles of a system acquire energy are called degrees of freedom. डिग्रीज ऑफ फ्रीडम किसी डायनेमिकल सिस्टम का टोटल नंबर ऑफ इंडिपेंडेंट कोऑर्डिनेट्स है. दोज कोऑर्डिनेट्स मे बी ट्रांसलेशनल और ट्रांसलेशनल एंड रोटेशनल बोथ, जिनके हेल्प से किसी डायनामिकल सिस्टम के पोजीशन और कन्फिगरेशन मीन्स द अरेंजमेंट ऑफ कंस्टिट्यूएंट्स ऑफ ए सिस्टम इन अ स्पेस. तो किसी डायनामिकल सिस्टम के पोजीशन और कन्फिगरेशन को कंप्लीटली स्पेसिफाई करने के लिए नंबर ऑफ इंडिपेंडेंट कोऑर्डिनेट्स को डिग्रीज ऑफ फ्रीडम कहा जाता है. डिग्रीज ऑफ फ्रीडम इज डिनोटेड बाय द सिंबल अ स्मॉल f. If a particle is restricted to move along a straight line, then it has only one degree of freedom. Its position can be specified from the origin by the displacement of the particle along either x-axis or y-axis or z-axis. जब कोई पार्टिकल स्ट्रेट लाइन मोशन में है तो उसके पोजीशन को ऑरिजिन से उसके डिस्प्लेसमेंट, किसी इंस्टेंट पर किसी समय उसका डिस्प्लेसमेंट से उसका पोजीशन को स्पेसिफाई किया जा सकता है, उस पार्टिकल के पोजीशन को आइदर अलोंग एक्स एक्सिस और वाई एक्सिस और जेड एक्सिस. सो डिग्री ऑफ फ्रीडम of a particle restricted to move along the straight line is only one. But if a particle is restricted to move in a plane, then there are two independent coordinates needed to specify the position of the particle in that plane. So degrees of freedom for a particle restricted to move in a plane is 2, and if the particle is restricted to move in a space, then 3 coordinate axes are needed to specify the position of that particle in a space. यदि पार्टिकल स्पेस में मूव करता है तो उसके लिए 3 कोऑर्डिनेट एक्सिस, 3 इंडिपेंडेंट कोऑर्डिनेट्स की ज़रूरत होगी, क्योंकि वह पार्टिकल स्पेस में किसी भी एक्सिस के लॉन्ग आइदर एक्स और वाई और जेड के लॉन्ग मूव कर सकता है. बट इन केस ऑफ गैसेस, ए गैस मॉलिक्यूल मूव्स इन अ स्पेस. सो for a monoatomic gas, for example helium, argon, neon, etc. It has three independent coordinates to specify its position in a space, and three independent coordinates must be needed to specify the position of a monoatomic gas molecule in a space. Are only three translatory coordinates, that is either along x-axis or y-axis or z-axis, because a monoatomic gas can move randomly in any of the coordinate axes. So degrees of freedom for a monoatomic gas are three, that is three translational degree of freedom, that is along x-axis, along y-axis and along z-axis, that is in x-y-z plane. So write down for a monoatomic gas, for example helium, neon, argon, etc. Total number of degrees of freedom equals to 3, or 3, that is three translational coordinates, not rotational in case of a monoatomic gas. A monoatomic gas can rotate, but its moment of inertia is very small because mass is very small. Hence, its rotational motion can be ignored. Therefore, only three translational coordinates, that is along x-axis, y-axis and z-axis. Only translatory motion of a diatomic molecule occur along x, y and z axis, that is x, y, z plane in a space. So for a monoatomic gas, total number of degrees of freedom is equal to 3, and only 3 translational degree of freedom. 3 translational degrees of freedom. 3 translational degrees of freedom. Now for a diatomic molecule, for example O2, N2, H2, total degrees of freedom are 3 translational and 2 rotational, because in figure 1b a diatomic molecule is attached to each other. So this system can move independently along x-axis, y-axis and z-axis. Therefore, there are 3 independent coordinates, that is for translational motion, and this system, that is the system of a diatomic molecule, that is system of 2 atoms, can rotate about 2 perpendicular axes passing through its center of mass. If a diatomic molecule is lying along x-axis, so this system can rotate perpendicular to its center of mass, that is along y-axis, and also another perpendicular axis, z-axis, both. So total degrees of freedom for a diatomic gas are 3 translational degrees of freedom and 2 rotational. Therefore, total degrees of freedom for a diatomic gas molecule is are 3 plus 2, that is 5. Write down for a diatomic molecule, gas molecule, for example O2, H2, N2, etc. Total number of independent coordinates, total number of independent coordinates or degrees of freedom are 3. That is degrees of freedom. Total number of independent coordinates को ही degrees of freedom कहा जाता है. So degrees of freedom equals to 3 translational plus 2 rotational, that is 3 plus 2, that is 5. A diatomic molecule cannot rotate about its axis. Suppose it is along x-axis. So it cannot rotate along the x-axis, but it can rotate perpendicular it can rotate easily about two perpendicular axes, say y-axis and z-axis, passing through its center of mass. So total number of independent coordinates for a diatomic molecule or degrees of freedom, which is called total number of independent coordinates are called degrees of freedom. So total number of independent coordinates or degrees of freedom for a diatomic molecule are 3 translational coordinates for translational motion along x-axis, y-axis and z-axis, that is a straight line motion along x-axis, y-axis and z-axis, and 2 rotational motion, that is total degrees of freedom for a diatomic molecules are 3 plus 2, that is 5. A triatomic molecule, for example H2O, SO2, etc. Total degrees of freedom, that is total number of independent coordinates, total degrees of freedom equals to 3 translational plus 3 rotational, that is 3 plus 3, that is 3 translational coordinates plus 3 rotational coordinates. Total degrees of freedom for a triatomic molecule. Triatomic molecule may be liquid or gases. So it is 3 plus 3, that is 6 total degrees of freedom. Now second topic of this video we have to discuss is the law of equipartition of energy, a very important law which states that the total energy of a thermodynamic system, for example a gas in thermal equilibrium, is equally distributed among its various degrees of freedom, and the energy associated with each degree of freedom per molecule is 1 by 2 kBT, where kB is Boltzmann constant, which is equal to 1.38 multiplied by 10 to power minus 23 joule per Kelvin, and capital T is the absolute temperature of the system, and it is called, this statement is called the law of equipartition of energy. किसी भी dynamic system का, for example gas, since gas molecules of a gas are in motion, so a gas is supposed to be a thermodynamic system. तो किसी भी thermodynamic system का total kinetic energy और internal energy उसके वेरियस डिग्रीज ऑफ फ्रीडम में, उसके बहुत से डिग्रीज ऑफ फ्रीडम में इक्वली डिस्ट्रीब्यूट हो जाता है, एंड फॉर ईच डिग्री ऑफ फ्रीडम पर मोलिक्यूल, मतलब ईच डिग्री ऑफ फ्रीडम के लिए ईच मोलिक्यूल को जो एनर्जी डिस्ट्रीब्यूट होगा उसका वैल्यू 1/2 kBT होता है, वेयर kB इज बोल्ट्जमैन कांस्टेंट. Kinetic energy of a gas molecule in a space is capital E equals to 1 by 2 m Vx square plus 1 by 2 m Vy square plus 1 by 2 m Vz square. Here we have taken three components of velocity of a gas molecule, because the motion of a gas molecule in a space is three-dimensional. So Vx is the x component of velocity of a gas molecule, Vy is the y component of velocity, and Vz is the z component of velocity of a gas molecule under consideration. And average kinetic energy for a gas molecule, that is capital E under angular bracket. एवरेज के लिए एंगुलर ब्रैकेट का सिंबल यूज किया जाता है. तो एवरेज काइनेटिक एनर्जी ऑफ ए गैस मोलिक्यूल इन स्पेस कैन बी रिटन एज कैपिटल ई एंगुलर ब्रैकेट अंडर एंगुलर ब्रैकेट इक्वल्स टू हाफ एम बी स्क्वायर अंडर एंगुलर ब्रैकेट, दैट इज एंगुलर ब्रैकेट हाफ एम भी एक्स स्क्वायर प्लस हाफ एम भी वाई स्क्वायर अंडर एंगुलर ब्रैकेट. हाफ एम भी वाई स्क्वायर को भी एंगुलर ब्रैकेट के अंदर रखना होगा एवरेज काइनेटिक एनर्जी के लिए, प्लस जेड एक्सिस के लॉन्ग काइनेटिक एनर्जी उस गैस मोलिक्यूल का कंपोनेंट वेलोसिटी का वी जेड है, तो हाफ एम भी जेड स्क्वायर, दैट इज हाफ एम भी जेड स्क्वायर. एंड इस डिग्री ऑफ फ्रीडम के लिए पर गैस मोलिक्यूल एनर्जी एसोसिएटेड कितना है 1/2 kBT. तो थ्री डायमेंशनल के लिए, थ्री डायमेंशनल मोशन के लिए इट विल बी इक्वल टू 3 × 1/2 kBT, दैट इज 3/2 kBT, दैट इज 3/2 kBT. सिंस ऑल डायरेक्शंस इन स्पेस आर इक्वली प्रीफर्ड, गैस मोलिक्यूल किसी भी डायरेक्शन में जब मोशन करेगा तो उसका किसी भी डायरेक्शन में मोशन कर सकता है. तो चूँकि इस डायरेक्शन इज इक्वल, देयरफॉर काइनेटिक एनर्जी ऑफ ए एवरेज काइनेटिक एनर्जी ऑफ ए गैस मोलिक्यूल along each direction, that is either along x direction or y direction or z direction, will be same. So we have half, that is half mv x square under angular bracket, that is average kinetic energy of a gas molecule along x axis, equals to 1/2 mv square mvy square under angular bracket equals to 1/2 mvz square under angular bracket equals to 1/2 kT, that is for per degree of freedom per molecule of a gas, energy distributed is or energy associated with each molecule per degree of freedom 1/2 kBT, and this is the law of equipartition of energy. किस डिग्री ऑफ फ्रीडम के लिए गैस मोलिक्यूल का इस डिग्री ऑफ फ्रीडम मीन्स इस डायरेक्शन में, दैट इज आइदर एलोंग एक्स एक्सिस और वाई एक्सिस और एलोंग जेड एक्सिस. तो पर मोलिक्यूल इस डिग्री ऑफ फ्रीडम के लिए एनर्जी एसोसिएटेड, काइनेटिक एनर्जी एसोसिएटेड, एवरेज काइनेटिक एनर्जी एसोसिएटेड विद द गैस मोलिक्यूल per degree of freedom is half 1/2 kBT, that is half average kinetic energy of the gas molecule along x-axis, that is under angular bracket half mv max square is equal to half kBT. Similarly, average kinetic energy of the gas molecule along y-axis, that is half m Vy square under angular bracket is also half kT, and along z-axis, that is average kinetic energy of the gas molecule along z-axis, that is half m Vz square under angular bracket is also half kBT. तो इस डिग्री ऑफ फ्रीडम के लिए गैस के इस मोलिक्यूल का पर डिग्री ऑफ फ्रीडम जो एनर्जी काइनेटिक एनर्जी एसोसिएटेड होता है, दैट इज हाफ kBT, एंड इट इज द लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी. Now last topic of this video we have to discuss is a specific heat capacities of gases. We know that gases have two specific heat capacities. Number one, Cp, that is a specific heat capacity at constant pressure, and number two, Cv, that is a specific heat capacity of a gas at constant volume. Total energy of 1 mole of an ideal gas is given by capital U equals to Na. Na is the Avogadro number multiplied by 1 by 2 F. F is the number of degrees of freedom, Kb into T. Or we can write capital U equals to 1 by 2 F Na into Kb into T. Now 1 by 2 F Na into Kb, that is Avogadro number, symbol is Na, and Kb is Boltzmann constant. So Na into Kb is R, capital R, gas constant. So it is, that is total energy, total internal energy of a mole or 1 mole of an ideal gas is final expression is capital U is equal to 1 by 2 F RT, where F is the total degrees of freedom of a gas molecule. Now Cv, a specific heat capacity of a gas at constant volume, is Cv is equal to du upon dt, and d upon dt, T is temperature, absolute temperature of the gas. So Cv is equal to a specific heat capacity of a gas at constant volume is given by Cv is equal to du upon dt, and it is d upon dt, and U is total internal energy of 1 mole of an ideal gas is 1 by 2 F, capital F R into T, and after differentiation 1 by 2 Fr, 1 by 2 F into R is constant, and it is d upon dt of T, d upon dt of T, that is 1. So Cv is equal to 1 by 2 Fr. Cv is 1 by 2, a specific heat capacity of a gas at constant volume, Cv is equal to 1 by 2 Fr, where F is the degree of freedom and capital R is gas constant. Now Cp, we know the relation, Mayer's formula, Cp minus Cv is equal to R. Since Cp minus Cv equals to R, capital R, therefore Cp equals to Cv plus capital R, and Cv is equal to, we have Cv is equal to 1 by 2 Fr in equation 2. So it is 1 by 2 a small f, which is the total number of degrees of freedom. So Cp is equal to Cv plus R, or Cp equals to 1 by 2 Fr, value of Cv from equation 2, plus capital R, which is gas constant, and it is R is common in both terms, so it is F upon 2 under bracket F upon 2 plus 1 out of the bracket, it is multiplied by R, capital R. So Cv is equal to 1 by 2 Fr in equation 2, and Cv is under bracket F upon 2 plus 1 bracket closed multiplied by R, capital R. Now we can obtain the ratio of two specific heat of gases, that is Cp by Cv, which is known as gamma. So gamma equals to, gamma is the ratio of two specific heat of gases, that is Cp upon Cv. Gamma is equal to Cp upon Cv. Cp is F upon 2 plus 1 multiplied by capital R, and Cv is 1 by 2 F into R, and we will obtain gamma equals to Cp upon CV equals to 1 plus 2 upon F. R and R will cancel out in RHS in numerator and denominator, and we will obtain gamma is equal to Cp by Cv equals to 1 plus 2 upon F, where F is the total degree of freedom, and it is equation number it is 4. Cp is equal to under bracket F by 2 plus 1 bracket closed multiplied by R. Say it is equation number 3 and it is equation number 4. For a monoatomic gas, we have for a monoatomic gas, total degree of freedom or number of independent coordinate we have already discussed in this video in the first topic. For a monoatomic gas, total degree of freedom is 3. So Cv, write down for monoatomic gases, Cv equals to formula is 1 by 2 Fr. डायरेक्ट फार्मूला हम लोगों ने ऑब्टेन किया. तो Cv इज इक्वल टू 1 by 2 F. डिग्री ऑफ फ्रीडम इज 3 into R, that is 3 by 2 R. For a monoatomic gas, specific heat capacity at constant volume is 3 by 2 R, and Cp equals to Cv plus R, और Cp के लिए डायरेक्ट फार्मूला भी हमने ऑब्टेन किया F by 2 plus 1 into R, that is F is equal to 3 F upon 2, that is F is replaced by 3 by 2 plus 1 bracket closed, out of the bracket it is capital R. 3 by 2 plus 1 multiplied by capital R, that is 3 plus 2, that is 5 by 2 into R, and say it is equation number Cv is for monoatomic gas is equation number 5, and Cp for a monoatomic gas is 5 by 2 R. Therefore gamma equals to 1 plus 2 by F. So a specific heat capacity, the ratio of to a specific heat of gases, gamma is equal to Cp by Cv, and it is डायरेक्ट फार्मूला इज Cp and Cv का वैल्यू भी सब्स्टिट्यूट करके ऑब्टेन किया जा सकता है. तो डायरेक्ट फार्मूला हमने ऑब्टेन किया 1 plus 2 1 अंडर ब्रैकेट 1 plus 2 upon F. So gamma equals to 1 plus 2 upon F, and F is degree of freedom for a monoatomic gas is 3. So it is 3 plus 2, that is 5 upon 3, and 5 upon 3 is 1.6666, that is 1.67. We can write it. Similarly for a diatomic gas or for diatomic gases, for monoatomic gases, degree of freedom F is equal to 3. Now for diatomic gases, for example O2, H2, N2, etc. we have already discussed it. So we have Cv equals to, for a diatomic gas, Cv is equal to 1 by 2 F into R, that is F is a number of total degree of freedom for diatomic gases, or for a diatomic gas is F equals to 3 plus 2, 3 translational degrees of freedom plus 2 rotational, that is 3 plus 2 5, that is Cv is equal to 1 by 2 F into R. फॉर्मूला है डायरेक्ट हमने ऑब्टेन किया. F equals to 5 multiplied by R, that is 5 upon 2 R, and Cp equals to it is equation number, say it is equation number 7, and Cp equals to Cp equal to F upon 2 डायरेक्ट फार्मूला, और नहीं तो अदरवाइज Cp इज इक्वल टू Cv प्लस R, वैसे भी ऑब्टेन कर सकते हैं अदरवाइज, बट हमने डायरेक्ट फार्मूला भी ऑब्टेन कर लिया है इक्वेशन नंबर 3 में. सो Cp दैट इज स्पेसिफिक हीट कैपेसिटी ऑफ ए डायटोमिक गैस एट कांस्टेंट प्रेशर. Cp इज इक्वल टू अंडर ब्रैकेट F by 2 plus 1 bracket closed multiplied by R. So F equals to 5 by 2 plus 1 multiplied by capital R, that is 7/2 upon 7/2 into capital R. Capital R is gas constant, say it is equation number 8. Now gamma, which is the ratio of Cp by Cv for a diatomic gas, is direct formula is 1 + 2/F. अदरवाइज Cp एंड Cv का वैल्यूज को भी, जो Cp और Cv का वैल्यूज है उसका रेशियो लेकर के भी, Cp इज 7, गामा इज टू Cp by Cv, Cp is 7/2 into R and Cv is 5/2 into R, that is R and R will cancel out, so it is 7/5. Other and alternately formula for gamma is in equation 4 we have obtained already. Gamma is equal to 1, gamma is equal to Cp by Cv is equal to 1 + 2/F, that is 1 plus, using the formula 1 + 2/F, capital F is equal to 5. Total degrees of freedom for a diatomic gas, it is 1 + 2/5, that is 7/5, and it is 1.4. So for diatomic gases, total degree of freedom F is equal to 5 and ratio of two specific heat of gases Cp by Cv is equal to gamma equals to 1.4. And finally for triatomic gases we have degrees of freedom. Total degrees of freedom is 3 translational plus 3 rotational, that is total degrees of freedom for for a triatomic gas or triatomic gases are 3 + 3 translational degrees of freedom and 3 rotational, that is 6, total 6 degrees of freedom. So write down in last for triatomic gases, we have Cv, degree of freedom F is equal to 6 and Cv equals to 1/2, that is F/2R, that is 6/2 into capital R, that is 3R. It is 3R. Cv is equal to formula is for Cv is F/2 into R, that is 6/2. Degree of freedom for triatomic gases are 6, so it is 6/2 into R, that is 3R, and Cp is equal to F/2 plus bracket, formula is under bracket F/2 plus 1 into R, so it is F is degree of freedom is 6, so 6/2 plus 1 into R, that is 4R. So Cp for a triatomic gas is 4R, using the formula Cp is equal to under bracket F/2 plus 1 into R. F is 6, degree of freedom for a triatomic gas is 6, so 6/2 plus 1, that is 6/2 is 3 plus 1, that is 4 into R. And say it is Cv for triatomic gas which is 3R, say it is equation number 9, and Cv for a triatomic gas which is we have obtained it as 4R. Therefore gamma, that is a specific heat capacity of a triatomic gas is gamma is equal to Cp upon Cv. Cp is 4R upon Cv is 3R. R and R in the denominator and numerator will cancel out, though therefore we have gamma is equal to 4/3 and it is 4/3 is 1.33. So for triatomic gases, the ratio of two specific heats, that is Cp by Cv, that is gamma is equal to 1.33. Now this video is completed. Thanks all of you for watching my YouTube channel Physics Quantum Classes. यदि यह वीडियो आप सभी को पसंद आया हो तो इस वीडियो को अधिक से अधिक लाइक करें तथा मेरे YouTube चैनल फिजिक्स क्वांटम क्लासेस को भी अधिक से अधिक नंबर्स में सब्सक्राइब करें